Wire rope slings are indispensable to an industrial world. Almost unnoticed, they arc across the skies of every major city. They provide the steel connection between power and load. Correctly used and maintained, they give efficient and trouble-free service in a wide variety of operations. Although slinging has been an everyday occurrence since man first made ropes, it is always possible for accidents to happen. Therefore, proper slinging methods need to be known and used. As construction and development proceeds apace, often over public traffic, it is necessary to ensure the safe use of slings. So there are statutory regulations governing all lifting tackle in building, factories and mines, and these should be known and observed. Wire rope slings have many applications in industry, and users need to be aware of the sling's limitations, determined by the rope's safe mass load, the working angle, and operation condition damage. So let's take a closer look at a wire rope sling. The raw material is a hot-rolled steel rod. Heat treatment ensures that it is suitable for successful cold working or drawing. In the drawing process, capstans pull the rod through a series of ever-decreasing dies until it is reduced to a steel wire with optimum tensile strength and ductility. These drawn wires are checked in a mill to ensure that they have achieved the desired characteristics for rope manufacture. The individual steel wires are then twisted together to form a strand. Six of these strands are loaded onto a closing machine to be spun through closing dies to produce a flexible steel wire suitable for sling manufacture. And then the riggers set about untwisting it in order to intertwine it back in a new form to make the super loop, a particularly neat and efficient termination for sling manufacture. The loop is a Flemish eye which ensures equal distribution of load in both parts of the eye. The final operation is the securing of the tails using a steel ferrule. A 3,000-ton press makes it possible to squeeze this ferrule until the steel flows into the spaces between the wires and strands. This forms a very strong and efficient bond. The completed super loop has no dangerous projecting wires and is neat and slim to permit easy withdrawal after depositing loads. All ferrule secured eyes can be proof loaded on request. In this test, the sling assembly is subjected to a load equal to twice its designed safe working load. This ensures that any malpractice or defective component is uncovered before the sling is put to work. Quality controllers check each sling for conformance of ferrule and eye dimensions. This indicates that the die tolerances and pressures were correct and that the splice will have optimum strength. Every termination in a sling assembly is given the same inspection. The test certificate assures the customer that the sling complies with the requirement of the order and has been successfully proof-loaded. Hand splices are still made for certain applications. The rope is bent around the thimble, the strands are opened out. A spike is driven behind a strand close to the thimble, one of the tails is inserted through the gap, and the tuck is worked tightly into the main part of the rope. There are several ways of making the first series of these tucks in hand splicing, but in all cases, a strand must emerge from each of the 6 interstices in the main part of the rope. The Admiralty or cross-tuck splice is preferred because the tails of the splice are not affected or loosened by any rope rotation which might occur in service. The Liverpool splice, although easier to execute, is not recommended for slings because it could unlay if the end of the rope is free to spin. Haggie Rand also do not recommend wire rope clip terminations for slings. In slinging operations, they could snag too easily and can pull out when the load is applied. It is of the utmost importance to use safe end terminations for every application. White metal or zinc socketing is done by evenly heating a suitable socket fitting into which has been inserted a thoroughly cleaned and fluxed rope end with the wires in the strands well brushed out and separated. The molten metal, controlled at a specific temperature, is poured into the socket to secure the rope. This termination is very neat and has 100% efficiency. Half-grip mechanical splicing is an efficient and economical way of making slings using pressed aluminium alloy ferrules. Thimbles are easily included in half-grip splices to give support to the eye. Purpose-made end fittings can also be swaged directly onto the steel wire rope. Where required, turnbuckles can be made integral with the eye, and sling hooks are most securely attached by mechanical splices. Every load that is lifted is of value to someone. Therefore, slinging means slinging safely. It means selecting the correct slings, using the proper slinging methods, and observing the necessary precautions. The stability of the load is important. A 4-legged sling, combined with 2 smaller slings, supports wide loads safely. Before lifting any load, its mass should be determined. This crate could weigh as little as 200 kilograms or as much as 20 tons. Never take a guess at the mass and just grab any sling that ought to be adequate. Battens under the crate protect the slings when the load is deposited. Loads should never be dropped on the slings, as these will be crushed and be unsafe for further use. The damage caused by unprotected sharp edges will drastically reduce the sling's load carrying ability. Sharp edges, particularly metal ones, should be padded. For narrow loads, the 2-legged sling combination with proper end terminations provides a safe lift. 2- or 4-legged slings are not intended for hooking back. This causes damage to the rope. And it is bad practice to have slings not in use carried on the hook with the load. Proper reeving slings should be used for lifting channel or tubes. As the weight of the load is taken, the slings will tighten and hold the load securely. A single sling is unsafe for long loads. the friction between the hook and the rope is insufficient to prevent the load slewing. Rather than guess the balance point for another try, 2 reeving slings should be used. Each is attached to the hook, which is placed centrally over the load. It is bad practice to force the bight of reeving slings down on the load. The included angle should never exceed 120 degrees, and this type of treatment only damages the rope severely. An alternate method, where a bight is wanted, is the single choker sling. A stirrup can be fitted temporarily in the bight. Where movement of the load could be a problem, double wrap slings can be used to grip the load and prevent it slipping. Coils can be lifted with simple cradle slings, but the angle between the sling legs will affect the safe working load. If at 30 degrees, the safe mass load is 9,6 tons, and we increase the angle to 60 degrees, the safe load is reduced to 8,6 tons. At 90 degrees, the figure is only 7 tons. And at 120 degrees, the safe load is just 1/2 of the 10 tons the 2 legs could support at 0 degrees. Carefully prepared charts, supplied by the manufacturers in all languages, can be consulted to find these safe working loads. The safe working loads of slings can also be severely reduced by abuse in the yard. Dragging lifting tackle across the ground under the weight of the load, or pulling slings out from under a deposited load, causes abrasive wear of the outer wires. A new sling can be severely worn on its first lift, and if the outer wires are reduced to half their original diameter, the sling is unfit for any further use. Leaving lifting tackle lying around after use is another sure way to reduce the safe lifting capacity of a wire rope sling. At exemplary rigging facilities, every sling is returned to the rigging shop immediately after use. Here, it is carefully examined by a responsible person for damage or deterioration. Serviceable slings are correctly stored on pegs or racks in a dry place to prevent damage or deterioration. A color coding system clearly identifies the tackle size and application of every sling, and large wall charts throughout the plant detail for other workmen the safe working load applicable to each color code. This is an ideal internal method of rating slings, and the fresh paint is a good mark of inspection and serviceability of both new and used slings. Alternative methods, such as stamping the ferules or fitting coded washers on the eyes, can be used, but every sling should be marked in some way to indicate clearly its safe working load. Apart from internal post or pre-use inspection, there are statutory requirements that certain slings be examined every 3 months by a competent person. The discard criteria are broken wires in excess of 5% over any length of 10 diameters, corrosion which is more than slight, serious defects or rope-destroying knots, sling hooks strained open, or kinks which cannot be repaired with a copper hammer. Steel wire rope slings which are found to be unfit for service cannot be derated. They must be destroyed by some irreversible action. The really heavy lifts are usually carefully planned. The tandem cranes are maneuvered precisely over the center of the load, and the riggers, in regulation safety wear, manipulate the huge tackle into place. Only the correct slings, in first-class condition, are used for lifts of this magnitude. The cranes take the strain with no snatch, and a gigantic load eases into space, dwarfing the slender steel connection on which it hangs. It is a versatile tool, devised to move every object man conceives safely. The indispensable wire rope sling.